2.6, we're not learning anything new. We're gonna just go with all those theorems that we just did, and we're gonna do some proofs with them, okay? And this is that thing where we were talking about when no one is expecting you to be able to just walk into this proof thing and just like start running marathons, doing an Ironman or something. We're not expecting that. I am expecting you to, we're learning how to stand up right now. We're learning what even proofs do, how they even work. We're going to do a construction first, okay? So we're going to learn a construction. We're going to learn how to practice the proofs, okay? I'm going to pause this. All right, I want you to, this is on the first page of 2.6. We just did a whole bunch of new theorems, and you need to get them in your mind on how to use them. So this is not a proof. It even says that at the top. This is not a proof. Write the definition, postulate, property, or theorem that justifies the statement about this diagram. Okay, your diagram, this is right there.
1A?
1A. 1A. We're going to do this together. Because you need to get these theorems and postulates in your mind, realizing that you should probably have your postulate book out or those theorem sheets out. And I want to know what theorem or postulate or property says that AD plus DB equals AB.
Segment addition postulate.
Is she right? Why is it not angle addition postulate?
Because we're doing it with segments, not angles.
AD, I'm going to even mark it up here so I can see it. AD plus DB equals the whole thing. You agree that that's true? Yes. The answer, the reason, is segment addition postulate. All right. I want you to try number 2 by yourself. I'm going to give you a couple of minutes. No. I'll give you about a minute. You look at number 1. If you need to mark it with your pencil, where's number 1? Where's number 2? Where's C, D, B? And see if you can figure out the answer for number 2. These reasons are in your postulate book or in your there will be one of these kind of things on your test and your review, so you can get more practice.
Wait, are we figuring out how to get from there to...
No, good question, Amy. Now it's a new statement. We're not trying to get from 1 to 2 now. No. I just want to know, based on this diagram, why is angle 1 plus angle 2 equal to CDB? We're not moving down in proof. This is not a proof at all. That's a wonderful question that you asked, Amy. I just want to know, how do we know that angle 1 plus angle 2 is angle CDB? What postulate says that that's true? Or theorem or property? How many know?
I think
Amy, what do you think?
I got angle addition postulate.
That is correct. Angle addition postulate.
I kind of knew as soon as I looked at it, but...
Okay. This is one of those things that once you see it now, maybe when you see it again, you'll go, oh, wow, we did this before. If you don't know it now, that's fine. You're going to see it again and again and again. All right. I want to know, how do we know that angle, I'm going to let you look in your book, how do we know that angle 2 is equal to angle 4? Congruent in this case.
You mean congruent to angle 6?
Did I say that wrong? I did. Angle 2 congruent to angle 6. Thank you. If you need to look in through your postulate book, or you need to look in your sheets, it's something we learned today.
Yeah.
It's something brand new we learned today. Numbers 1 and 2 we learned last unit, so those were a while ago.
Wait, where got my...
I don't have a print everything, print like anything out.
stress.
So, I have no idea.
Okay. Thank you for letting me know.
Wait, I'm missing my
Paper.
the things you just spoke to.
Definitions?
Yeah, I think I'm my bad.
You don't have them in here?
Well, I don't have all of them, but I have that. I didn't think I was supposed to write all of them.
You have what you're supposed to.
Okay.
Look, it's on that page. Listen to
Oh,
it.
okay. I didn't.
Okay.
Oh,
All right, why- What kind of angles are angle 2 and 6? Right there. Right?
Vertical lines.
They're vertical angles. This is the vertical angle theorem.
I lost my page.
2.61a.
And I abbreviated vert angles theorem. Okay?
Yeah, that's right.
This vertical.
Those two are vertical angles. That's why they're equal or congruent in this case. Okay? All right.
Angle. Yeah.
Uh-huh. I think I know number 4.
Number 4 says that if D is the midpoint, I'm going to mark it. I have to mark it personally, everybody. So D is right there. And if it's the middle or the midpoint of this whole thing, Y is AD congruent or equal to DB. We have used this before, one time, maybe just in a video that I did, but not necessarily in homework. Why are those equal? I'm going to tell you that it's a definition. You won't have this one in your Postulate book.
Yeah, I don't think I can.
It would have been in one of your definitions that we did with Unit 1, but it won't be in your Postulate book. Nariah, what is it?
Definition of midpoint.
It is the definition of midpoint. Okay. Again, these are something where you're learning as you go. Now that if you'll see this in the future, something about things being in the midpoint, you'll know that it's the definition of midpoint is a reason. Number 5. I want you to mark angles ADF and angle FDB.
ADF.
Yes, that's where we're on, number 5. Got ADF. New color.
Wait.
FDB. Why are those equal to 180 degrees?
That yellow really shows up on the dark blue.
It does. It does. So I should keep it yellow. Number 5, just randomly, I'll just change to yellow. I was going to keep it kind of consistent.
Well, no, I was just.
I know. I totally agree.
I can see the purple just fine too.
What kind of angles are ADF? And are those vertical? Are these vertical right here?
No.
What are they? It's a new one. What is it, Nora?
Linear pair.
They are
It
linear
is.
pairs.
And-
What reason are they adding up to 180? It's a new one today.
The linear pair.
The linear pair postulate. Ah.
I need to stop second guessing myself.
All right. Number
Yeah.
6.
That one's confusing.
Number 6 says that if 4 and 3 are equal, then DG bisects angle BDE. Why can we say that it bisects? If
Yeah, I don't
Four-
know.
3 and 4, I'm going to erase all that up here from before. It's not pertinent anymore. 3 and 4 are equal, then that means that bisects. It won't be in your Postulate book. If it's not in your Postulate book, what does it mean it is? It's a definition. This is a definition. Definition of what?
Bisect?
Angle bisector, yes. This is the first time you've seen this. That's why we're going over this together. This is definition. Angle bisector.
Or do we have to put def? Or like definition?
You can put all of definition or just DEF. You can choose. Okay. Definition of angle bisector. Use my eraser to get rid of this stuff here. All right, number 7.
Oh.
If 4 is complementary to 5, and angle 6 is complementary to 5, then angle 4 is congruent to angle 6. This is a brand new theorem from today. I'm going to give you a hint with the word complementary. Notice we have a shared angle. 5 is in both of them. So 4 is complementary to 5 and 6 is complementary to 5. They're complementary to the same angle. There is a theorem that says if two angles are complementary to the same angle or congruent angles, then they are congruent. Heidi, do you know which one that is?
Complement. Wait, no. Is it complement there?
It is. I'm going to,
Oh, it is?
yes, congruent complements theorem. Did she say supplements?
No.
No,
It
I
is-
said right angle.
It's
Congruent.
No, because they're not right angles.
Yeah.
So this is congruent complements.
But complementary means that they add up to be 90, doesn't it?
Yes. So if 4 and 5 add up to 90 degrees, and if 6 and 5 add up to 90 degrees, then 4 and 6 have to be equal. Congruent complements theorem. Okay. You're going to use those. You need to know those, and you need to know why those, so that we can use them as we go along. So read these over, know where they are in your postulate book, get them in their postulate book if they're not there. We have mark 1 and 4 being congruent, because that's the given. Okay?
Wait.
That's right.
Oh,
And I'm going to give you a second step now. First, you mark your diagram. Second, you look at your diagram and see if your diagram tells you anything new. Can you look at your diagram and decide there's something true about this based on what it looks like? Is there a relationship between any of the angles? What kind of angles are they? Are they vertical? Are there any vertical angles up there?
No.
There are no, so we can't say they're equal. What else do we know?
1 and 2 and 3 and 4 are linear pairs.
1 and 2 and 3 and 4 are linear pairs, right? So we could say that 1 and 2 is supplementary and 3 and 4 are supplementary, correct?
Yes.
Okay. That's not what I'm looking for. This is what I'm looking for. Okay, so we know, I'm going to just, so in a sense we got 1 and 4 being, I'm going to do what you liked. You liked my yellow. Those are congruent. And I can say that those are supplementary or equal 180. And that equals 180. Now, I will have to put a reason for these. Given is for the yellows, right? Because given's already done. So I can, so that for that part, I needed to fast. All right. Do you have any of your postulates that talk about something being supplementary?
Linear pair postulate?
Linear pair postulate. So we could say that 1 and 2 and 3 and 4 are supplementary because of linear pair postulate. Is there anything else that talks about supplementary? Keep looking, keep looking. Heidi knows.
I don't know.
You don't know. Anything else that talks about supplementary that we just learned today?
Congruent supplements?
What does the congruent supplements theorem say?
2 angles that are supplementary to the same angle are congruent. When 2 congruent angles, they are congruent.
Are we trying, so then they are congruent. You got that at the end. Are we trying to get something congruent?
Yes.
Do we have some things that are supplementary?
Yes.
So maybe we can use this one. Okay, so we're trying to get something congruent. That's what our proof, right? And we're trying to get 1 and 4 to be, they are congruent. We're trying to get 2 and 3 to be congruent. Is 2 and 3 supplementary to the same angle?
No, but they're supplementary to two angles that are congruent.
They're supplementary to 2 angles that are congruent. So let's think about this. If angle 1, which is obtuse here, is 120, this has to be 120 because it says they're equal, right? So what does 2 have to be? If they're, because we know they add up to 180.
60.
60, because these two add to 180, right?
Mm-hmm.
So what does 3 have to be?
60.
60 also, right? Because they're supplementary to the congruent angles. Okay, so I have just in my mind worked out a plan. Let's see how we can write it down. Now you've heard my plan. Number 1, we're going to write the given is that angle 1 is congruent to angle 4. Reason is what? Given. We said we had 2 things that we knew. One thing we knew these 2 things up here. And why is angle 1 and 2 add up to 180? What's the reason?
Because they're supplementary, so that's
There was a reason that we learned today that what kind of angles are 1 and 2?
linear pair.
So why do they add up to 180?
Linear pair
The
postulate.
linear pair postulate. So we're going to say supplementary instead of equal 180. Angle 1 and angle 2 are supplementary. And you don't have to write the R, you can just do sub. Angle 3 and angle 4 are supplementary. And we said reason was what? Besides Narayan, because you're doing so great. And I just want to know, what reason did we give over here?
I have no idea.
Do you remember, Josie? Amy, do you remember? Do you remember, Heidi? You
Linear something or other. Linear.
linear pair. Linear pair what?
Postulate.
Postulate. Okay. All right, your linear pair postulate says, the linear pair postulate says that linear pairs are supplementary. Okay, so we know that angle 1 is supplementary to 2 and 3 is supplementary to 4. Is there a link between 1 and 4?
Yes, they're congruent.
They're congruent. Let me just highlight that. 1 and 4 are congruent. So if 2 and 3 are supplementary to congruent angles, then they are congruent. So I can right now say angle 2 is congruent to angle 3. Why?
Complementary congruence.
Not complementary,
So
supplementary, and it's called the congruent complements theorem.
Wait, so the congruent column.
Did I say complement?
Yeah.
Supplement. Congruent supplements theorem. Okay. I have 1 minute. I'm going to go back here. This one we had, right? Just 1 second.
Wait, we're not done.
Just watch this. We are done.
Yes, we are.
We're
Yes,
done.
we are.
I want you to look at this one for a minute. I'm not going to do the proof, I promise. What if first thing I would do, I told you there was 2 things you need to do. First, you do what when you're doing to do a proof?
Mark your diagram.
So I would mark that 2 and 3 are congruent, correct? Then I will look at this and I'll find something that's true about it. What's true about this? Based on that diagram.
3 and 4. Yeah, vertical.
They're vertical angles. So what's congruent, Heidi? 3 and 4 are congruent. 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 3 and 4 are Not 1 and 4, not yet. Which ones are vertical ones?
1 and 2.
Yes. Somewhere I could write that angle 1 is congruent to angle 2. By vertical angles theorem, I could somewhere in there write angle 3 is congruent to angle 4 somewhere in there, right? Okay? And if you knew that angle 2 was congruent to angle 3, you know that by the given. Is there anything, these two share, right? These two share an angle 2. So what do you know about angle 1 and 3? If angle 2 is equal to angle 3 and angle 2 is equal to angle 1, they're equal by transitive property, right?
Yeah.
So I could write that angle 1 and angle 3 were congruent. Now we share an angle 3, so what can we do with these two?
Angle 4 and angle 1 are congruent.
And that's where we were, okay? This one was the best one to do.